Good morning. I've scraped some of the snow off my two solar panels here. These are 225s each and produce about 60 volts. And everyone shows you fabulous days, but I'm going to show you what happens on absolutely the worst day. I don't know if it's kind of focusing on the screen, but most of the panel is covered. There are some places where the snow is about 4 inches thick. We don't really expect much from this, and everyone does videos about fabulous sunny days, but I find these low light conditions more interesting. This is the TL4, the FET driver, and I've modified this a little bit. You know, I have these .22s, and I use them for about everything, and the reason I do that is I got a couple thousand of them, so, you know, that's what I use. But I went back and made this a little faster because, you know, I saw this one video of this guy in Chechnya, and he's doing it with a single 220 UF, and I just wanted to see what would happen with that. And I found out that capacitors would start heating up. So this is my signal right here, and this is 120 microseconds, the power pulse. So 120 microseconds is all the power you can store in these two capacitors. Now, one of these says it's 212 microfarads and 0.437 ohms for the ESR. This one is 245 and it's 0.115 ohms. So yeah, these are kind of high resistance, and it was heating up slightly at a little more power than this, but yeah, you don't want to heat up capacitors. And the voltage differential, so this right now is operating at about 15 hertz, I think, somewhere in that region. So things aren't focusing very well, but yeah, that's low power, and you can see the panels are snow covered, and we're still getting some power out of this. So these low light level conditions are great for seeing how much energy your capacitor is really storing, because, you know, it's a very short pulse, and it's a long time between the next one, and you're not getting much extra solar power from the panel as the capacitor is discharging. So what you're seeing is the total discharge, how much energy you can get. So my opinion of running with a 220 UF is pretty low. A single one, the capacitor heated up quite a bit, and there was a high differential voltage of about 10 volts. And that's way too high on 60 volts, so that's less efficient. Two capacitors would work pretty good. So, you know, like 3 220s would be, I think, an acceptable compromise if you're looking for something cheap. And you can get some of those, that much out of an old UPS or two PC power supplies. But here we are in the morning, 60 volts and less than 10 milliamps of current. And like I said, I sped it up so it would take these small values of capacitors. That's it. Pretty interesting.